Hello, this is still lesson 5. This is now the second page of the packet. I figured we'll make the videos a little bit shorter so you can go through them, do the page, stop, go back, hoping that's what you're doing. But now we're going to talk about a word problem. When we did these word problems in chapter 7, we had to make a big graph. And everything had to be labeled. You had to change your window, and then you had to put in what they're looking for is a straight line. You had to use the intersect button. We couldn't get through more than 2 problems, 3 if we were lucky in a class period. They were crazy. So now you're probably going to be mad, but we could do this problem really, really fast in chapter 8 using logarithms. So that's what this problem is all about. First, they give us this equation on the back of the second page. Why they started using Q, I don't know. For Q, they're talking quantity over time, initial quantity, and then here they're even using P for percent. We've never used that before, so I don't want to confuse you. Maybe cross that off, and let's write it the way we're used to seeing it. The amount over time is the initial amount or the principal. When you're dealing with money, we call it principal. And we always use R for the percentage rate. And I want to keep using R here. And time doesn't change. So if we fix this now, and we're using an equation that we're very comfortable with, and I hope you're comfortable with it because it really is the only equation that I've been using for chapter 7 and 8 so far. Now let's talk about this bat problem. A biologist is modeling the population of bats on a tropical island. When he first started observing them, there were 104 bats. That's my initial amount. The biologist believes that the bat population is growing. I am increasing by 3%. Part A, they want me to write an equation for the number of bats, and instead of amount over time, they want me to use bats over time. Okay, they want me to change the variable. They can do that in the problem when they tell us to. So we had 104 bats to begin with. We're keeping our 100% of our bats. Remember, the 1 means I'm keeping 100%. Keeping all 104, and now I am increasing by 3% over time. So there's my equation. Now they want me to figure out how long will it take to reach 200 bats. So now this becomes my 200. And if we were doing chapter 7, we would have had the straight line through the 200. So how did this happen? Well, we have 104 and we have 1.03 to the time. So just like on lesson 4, solving, we have to, divide out this 104. And when we do that, we're going to get a really long decimal number that I'm just going to let my calculator hold on to. 200 divided by 104 gives me 1.923076923. Hopefully you get the same thing. Hold that on your calculator. Because now I'm going to do what I would do, what the calculator would show in class. I'm going to put a log on both sides, and I'm going to use a natural log, and I'm just going to use the answer key on the calculator. I'm going to let the calculator hold that big number. And when I put a natural log on this side, power rule brings the t down in front. And so now to solve for t, I'm going to divide by the natural log of 1.03. So on my calculator, again, here we go. I'm going to hit natural log, second answer, just like we had said. So there it is. And then we're going to divide this by the natural log of 1.03. And now I get 22.1229 years. They said round it to the nearest year. 22 years. So it will take 22 years at this growth rate to get to 22 bats on this island. Makes the work a whole lot faster and a whole lot easier, doesn't it? So hopefully you've been doing all your work with the prior lessons, and so this lesson now should feel a whole lot better. Now, exercise 5 is talking about stock that's declining at 5% per week. Well, we gotta get rid of some of this stuff here, and let's write this down. So I'm gonna keep all of this, as I will fill this in. I'm declining, which means I'm not keeping 100%. When I'm declining, if you recall, we're going to be subtracting from 100%. So let's write down the important information on this problem. Always make a list of important information. Okay, so a stock has been declining at 5% per week. So you are 0.05 going down. That means the 100% of your money minus the 5% of your money that you're losing, you are keeping 95%. So we talked about that in class. You guys were really good with that. Just to remind you again, if the stock price started at $22.50, so the initial amount $22.50, the initial principal, because now we can use this or P for principal, and it says determine the number of weeks it will take for the price to reach $10. So now the amount over time is $10. So we take our equation and we fill it in. We have $10 is equal to the initial or the principal. We lost 5%, which means we're keeping 95% over time. And just like the problem we just did, we're going to divide out this $22.50 because we got to get the parenthesis by himself. And so 10 divided by $22.50, I cannot do that in my head, and I don't think you can either, gives me 0.4 repeating. So I'll just use that repeat bar. This canceled over here, and now I have 0.95 to the time, 0.95 to the time. If I put a natural log on 0.4 repeating, I do the same thing, and I have t times the natural log of 0.95. I'm going to divide by the natural log of 0.95. And now on my calculator, the 0.4 repeating is still there. Didn't clear it. Natural log of that repeat, I'll use the answer key. I'm now going to divide by the natural log of 0.95, and I get 15.8096 for an answer. And they wanted me to round to, oh, this isn't years, this is weeks, sorry about that, to the nearest week. 15.8 rounds to 16 weeks. Definitely a lot easier when you're using logs. Now, the other thing, the last thing that we did on the lesson 4, you were doing a lot of solving with the natural log. You guys were handing in beautiful work. I have to say, I was so happy with the work you guys have been handing in. And a lot of people are asking questions, and I hope that I'm helping you with my answers. So please keep those questions coming. Anything and everything you don't understand, you have to let me know. And I truly will do everything in my power to help you out. All right, so now we're on exercise 6, and we're back to problems that look just like lesson 4. 4 times 2 to the x minus 3 is equal to 17. Now, remember, just like in class, I would always tell you, PEMDAS in reverse. Please excuse my dear Aunt Sally. We are starting here and working it this way. Add, subtract. Well, here's a subtract. That means I have to add. So let's do that. Now I have 4 times 2 to the x is equal to 20. Order of operations is a roadmap. Use it, you will be successful. Now I'm up to multiply, divide. Here's multiplication. I'm going to divide. Divide by 4. Now I have 2 to the x is equal to 5. Now I'm up to exponent. Get rid of exponents with the log. So power rule, x times the natural log of 2 is equal to the natural log of 5. I'm going to divide both sides by the natural log of 2. And let's see what we get here. Natural log of 5 divided by the natural log of 2. And I get 2.3219. They told me that they didn't tell me how to round. Well, if they don't tell me how to round, my only option is to write the answer. 2.3219280095. They also said, you know, you can write this going from here into log form. You can. X is the exponent on a base of 2. So x is the exponent on a base of 2. Remember, the x and the 5 switch. So then there would be your 5. If you typed this in, you're getting right back to this answer. So this is going back to lesson 1, not chapter 1, lesson 1. If you want to take it and do that, and again, you type in the log of 5 divided by the log of 2, you're getting the exact same answer. And that's another, you know, good little review. Make sure you get the same answer, and then you'll feel better about things. Let's take a look at B. B has, and I'm just going to go down a little lower so I can write easier. So B has 17 times 5 to the x divided by 3 equals 4. So this guy doesn't look as pretty. It doesn't matter if it looks pretty or if it doesn't look pretty. PEMDAS in reverse. Start here, no add or subtract, so I don't need it. Here I have multiplication. I'm going to use division. So I'm going to divide by 17. Now, this is a proper fraction. I can actually leave this if I wanted to. And I can just let the calculator do that later, so maybe I'll do that. If I put a log on both sides, I get x divided by 3, natural log of 5, is equal to the natural log of 4/17. And I'm going to divide by the natural log of 5. And here I have x over 3. Now I want my number. So now I'm typing everything in on the calculator. So the first thing, I'll type natural log 4 divided by 17 in the parenthesis. So make sure you keep that in the parenthesis. Now divide by the natural log of 5. And we get negative 0.89902. And opposite of division is multiplication. So this whole big number has to be multiplied by 3. But of course, I'm going to let the calculator do that. So times by 3. And my x now, I'm going to come up here just so I can write neatly. X is negative 2.6971 I have no room to write, and I did tell you that as long as you are not less than 4 decimal places, that is the only time you can round. So here's the first 2 pages of the packet. Your homework are the second 2 pages. Please back up and look through the lesson. The first video is all page 1. The second video is page 2. And I'm also going to upload, if you need, the author's video from YouTube on how he would approach this packet, and maybe the different perspectives will help you. Please email me if you need my help. Good luck. See you later.